we'll get into some quantitative interpretation of velocity time graphs, and specifically how to look at a position time graph and make a velocity time graph that corresponds to it. So let's take this. This is a position time graph. And you have some object. It starts at a position of -4 relative to the reference point, and 2 seconds later it's at the reference point. So you're not given a ton of numbers in this, but you're certainly given enough information to find the slope. So you're asked to find velocity at the top there. How do you find velocity? Hopefully I did that. There we go. Average velocity, final position minus initial position over change in time. And this isn't really a final position. We could look at this as an x2 minus an x1. But it's all the same. It's a straight line, so any 2 points on the line would give you the same slope. Make sure the step down here, oops, let me head backwards. This step down here, 0 minus -4. A lot of people skip that. A lot of you think you can do the arithmetic in your head, and you can't. So I recommend writing it out so you know what's going on. We get a positive number, a +2, and just as by way of review, it should be positive. This is a positive slope. If you didn't get a positive number, you would know you screwed up. So it went up 4 units. It went from -4 to 0, so it went positive 4 units of distance in 2 seconds. Its velocity is 2 meters per second. And we know that what we just found was the slope of this line. And we know that average velocity is the slope of a position time graph. So hopefully this is old stuff, not a big deal. So if I wanted to go and make a velocity time graph out of this, what would I have? I would have an object traveling at a constant velocity of 2 meters per second. And this is what it would look like. I've changed my axes labels, velocity to time, and there it is. It's at a constant velocity of 2 meters per second. So you've got to check your axes when you look at these, even on a test or quiz. Make sure you know what kind of graph you're trying to interpret. Here's another one. So we want to draw the corresponding velocity time graph. Well, it's another object traveling at a nice constant velocity. A straight line in a position time graph indicates a constant velocity. This thing goes down 20 units, right? It starts at +20. 10 seconds later, it's at 0. So we can see that its slope is -2. And that means its velocity is -2. And so what would that graph look like? It would look like this, just a horizontal line at -2. This is showing something traveling at a constant velocity of 2 meters per second. And let me go back. This is showing something traveling at a constant velocity of 2 meters per second. Again, these graphs give us different information, but they're both showing a constant velocity of 2 meters per second. We can at least get that information from both of them. Here's another one. Oh my goodness, there's 2 lines. So we have a dashed line and a solid line. That dotted line there goes down 100 units. So it goes -100 in 5 seconds. -100 divided by 5 is -20. So that dotted line, or that dashed line, has a slope of -20. What does that mean? The slope of a position time graph's velocity. It means it has a velocity of -20. The solid line goes down 50 in 25 seconds. -50 over 25 is -2. So these are, this is the corresponding velocity time graph. One object that I drew with that solid line has a constant velocity of -2, the other -20. This is how I would draw the graph. So what do we have here? You have the solid line at this position of 40, and it's at a position of 40, and it never changes its position. So in a position time graph, that horizontal line means position isn't changing, and it means its velocity is 0. So the solid line shows a velocity of 0. That dotted line, we see that it goes up 50 units, right? That dotted line has a positive slope. It starts with a negative position, but so what? Slope is about where the line's going. It's not about where it is on that vertical axis. So it goes up 50 units of distance in 10 seconds. 50 over 10 is 5. So we have the dashed line with a slope of 5, and we have the solid line with a slope of 0. And so we would get a velocity time graph that looks like this. We have parallel lines here. They look parallel, and we can do a little bit of math and confirm that they're parallel. We have the solid line goes up 50 in 10 seconds. 50 over 10 is 5, +5. And we have the dotted line that goes up 75 in 15 seconds. 75 over 15 is also 5. So these are parallel lines. Parallel lines have the same slope. In a position time graph, parallel lines have the same velocity because the slope of a position time graph is velocity. So these would just be on the same line. And they would both have that velocity, a constant velocity of +5. This one's a little different, and this is more like what you're going to be seeing when you get problems. So for 5 seconds, this is one object. For 5 seconds, it's just standing there. It's just at positive 10. It's not doing anything. Hanging out. For 5 seconds, its velocity is 0. And then for the rest of the graph, during the rest of this event, its velocity is not 0. It has this negative velocity. We need to find out what it is. And this is where, let me see if I can get a pen that'll write. I wonder if this will change the slide on me. I'm not sure. But we know that for 5 seconds, right? Am I drawing? I'm drawing in red. Hang on. Here's my pen color. So from 5 to 10 seconds, over this period of 5 seconds, this thing goes down 10 meters. Now it keeps going down after that, but I'm not given any numbers here. So I'm gonna pick this point here because I actually know what these 2 points are. So it goes negative 10 in 5 seconds. That means it has a velocity of negative 2. So this object does 2 different things. For the first 5 seconds, it just sits there. For the rest of the event, it has a constant velocity of negative 2. And I have to indicate that in a velocity time graph. And this is another one of those things that is tricky for people in the beginning. So let's see how we do this. Oops, I'm still in my pen mode. Let's see how we do this. We calculate those velocities, which we already did. I don't know how to get rid of the writing. It's all one side. So the first 5 seconds, it's at 0. And for the rest of the event, remember, it's at negative 2. And I'm going to indicate that by starting at 5 seconds, showing this velocity of negative 2. This dotted line that is vertical is not part of the graph. It makes tracking the lines easier, though. It makes it easier for your eye to see where you're going and at what time these things are changing. So that would be how I would graph that one. Now we have this one. This is just horrible. So you can freeze this, freeze the screen. See if you can get this. See if you can make the corresponding velocity time graph. Be careful. And then I will put up the answer. So you can freeze it now. And you probably didn't freeze it, right? You're probably just waiting for the answer. So here, you could do this a couple of ways. This is a straight line here, running right from 60 to negative 60. So you could say, well, it goes down 120. Right? From 60 to negative 60 is 120. It goes down 120 in 10 seconds. So you could say, well, it's minus 120 over 10. And so the slope here is negative 12. You could also say it goes down 60 in 5 seconds and also get a slope of negative 12. So the slope of this first part of the line is negative 12. The slope of this is 0. And then here, just be careful, from 20 seconds onward, this is a span of 10 seconds. From 20 to 30. I'm not going to worry about what goes on up here because I don't know what any of those numbers are, right? I'm only given a few points on this graph. So it goes up 60 in 10 seconds. 60 over 10 is 6. So we find our slopes are negative 12, 0, and 6, respectively. And for the first 10 seconds, so I have to keep track of this when I make my velocity time graph, for the first 10 seconds, it's at a constant velocity of negative 12. For the next 10 seconds, it's at rest. And for the remainder of the event, however long this lasts, it is going at positive 6 meters per second. So to make my velocity time graph, I would put it like that. So 10 seconds at negative 12, 10 seconds at 0, and 10 seconds at positive 6.